Hi. Now I will be walking you through the fifth multiple choice question, and it refers to the same image as the previous question. So our physics facts, we're still going to need our physics facts from the previous one, from the previous problem, in which we emphasize the importance of breaking Newton's second law into components. So sum of forces in the x direction equals mass times acceleration in the x direction, and sum of forces in the y direction equals mass times the acceleration in the y direction. And we're going to need to draw a free body diagram. However, now another physics fact that is critical is that we know the force of friction is mu times the normal force. So that's going to come back very shortly. So F, because remember it says refer to force of friction as F, equals mu times Fn. And from before, our FBD is exactly the same. mg, the weight force. Up here we'll have our normal force, and up here and one more physics fact that we're gonna need later is that when when something is in equilibrium, the sum of the forces is equal to 0. So and then here F sine theta, and if you recall from the last video I explained sine theta for vertical because it's opposite over hypotenuse times the hypotenuse, which would just be the opposite. So it'd be like that. And then it's gonna be and then for horizontal it'll be F cosine theta, because adjacent over hypotenuse times hypotenuse would just be adjacent. And then this way we just have F. So before it was all about the sum of forces in the x direction. Now that's not nearly as important. We're going to focus on sum of forces in the y direction. And the sum of forces in the y direction, they do equal ma, but since it's in equilibrium, Ra is 0. So the sum of forces would be equal to 0. So Fn plus F sine theta minus mg equals 0. So that would mean our normal force equals mg minus F sine theta. And then this equation comes into play. We know our friction force, and it's asking to find mu, the coefficient of friction. Mu, this here is our coefficient of friction. So F equals mu times mg minus F sine theta. Okay, so now we solve for mu. We divide mg minus F sine theta by both sides. Mu equals F over mg minus F sine theta. And that is our answer. Matches up with answer E, F over mg minus F sine theta. Thank you very much.